Okay, next question. A circular cone is inscribed in a sphere as shown. The sphere has a center of O and a radius of 12. A is the vertex of the cone, B is a point on the base of the cone that touches the sphere, and C is center of the base of the cone. Okay. Right, so let OC is equal to X, so I have that in here. I don't know if you can see it. Okay. And it wants us to find BC, so this line here. Okay. Now, I have a little right angle triangle here. All right. So, in this right angled triangle, I have X, I have BC, which is what I'm looking for, and I actually have 12, okay, because O to B is the radius, okay, which is 12, okay, because it's center out to the point on the circle, and I can use Pythagoras' theorem. So 12 squared is equal to X squared plus BC squared, which gives us 144 is equal to X squared plus BC squared, and 144 minus X squared is equal to BC squared. The square root of 144 minus X squared is equal to BC. Okay, and you can leave it exactly like that. Okay, alternatively, if you did see here that this was the difference of two squares, okay, you could have said that this was the square root of 12 minus X, 12 plus X. Okay, but it's not needed. Okay, 144 minus X squared is absolutely perfect. Okay, the next question then asks you to show that the volume of the cone, so very first thing you're going to do is volume of a cone is a third pi r squared h is equal to 12 plus x squared times 12 minus x. Okay, so of the cone, I know that BC is the radius of the cone, and I've just found BC over here to be the square root of 144 minus x squared. Okay, so I've got 1/3 pi 144 minus x squared, sorry, the square root of that, squared, times h, which of the cone I know is sorry, the sphere is center, a radius O, and 12. And 12. Sorry, 12 is from A to O. Sorry, brain fart there. So 12, and then you've got to account for the additional bit there. So it's 12 plus x is the height of the cone. Okay, my square root cancel off. Okay, this is actually where you do have to see that 144 minus x squared can be simplified to 12 minus x, 12 plus x. And when I put that all together over here, I'll get a third pi 12 minus x, 12 plus x, which is 144 minus x, which is this bit, times 12 plus x. Okay, and you've got two 12 plus x's, so a third times pi can be written as pi over 3, top by top, bottom by bottom, 12 minus x and 12 plus x squared. Okay, I know my order is slightly different there, but as long as the squared is on the 12 plus x, okay, that is exactly the same as writing 12 plus x squared, 12 minus x. Okay, and remember when it says show that, you do really need to show this here. Okay. Okay, the next one, a water trough of uniform cross section and length L is shown in figure 1. Now, it's a water trough, which means that it's hollow. Okay, because it's obviously something that you fill with water. Okay, so I'm obviously filling it in here. Okay, Trough has a capacity of 112.5 litres. Now, 112.5 litres needs to be converted to centimetres cubed because my answer is in centimetres cubed. It says, show that the internal surface area of the trough is equal to 24x squared plus 93,750 over x. So, to start off with, I know that the area of the front surface, okay, so this is a volume, okay, and this is a prism. So, the area of a prism multiplied by the length that it goes back is equal to the volume. Okay, which means I need to find the area of this section here, okay, which is a triangle. So I need half the base times the height, okay. So to get the height, I've gone over here. So I know that it is an isosceles triangle. So when I cut this exactly in half, I'll have 4x and 4x, which together add up to the 8x. So I've got a right angle triangle here. That is 4x. I know that the hypotenuse is 5, and I want to find this. Okay, so I used Pythagoras' theorem, okay, to find out that that length there, the height, is 3x. Okay, so to find the area of that, it's half the base times the height. So half of the base, which is 8x, times the height, which is 3x, okay, which is a half 8 is 4, 4 times 3 is 12x squared is the area. So 12x squared times the length, which I can see from my diagram is L, is equal to that volume. Okay. So to get an expression here for L, okay, L is 112,500 divided by 12x squared. Okay, now that actually simplifies further to 9375 over x squared. Okay, so I know what my L is, and the importance of doing this was actually specifically to find L. Okay, and you can do that in different steps. You may have found other areas first and come back to this, but it is important that you get this, that you know you were given a volume, okay, and you're not given something just for the sake of it, that you were given it so that you could use it. Okay, if anybody doesn't understand anything there, please let me know. Okay, then I'm looking for the internal surface area. Okay, so first of all, I've got two triangles, two triangular faces at the front and at the back. So 12x squared plus 12x squared. Okay, and that's actually where I get my 24x squared. Okay, I've nothing at the top because remember that's hollow. And I've got two of these sides. And again, I'm actually going to change my pen. So two of this side here. Okay, which has, sorry. Okay, which is a rectangle as such. The length of that is 5x. Okay, so the rectangular sides, I know that looks like a parallelogram there, but remember, okay, you're looking at an angle. If you were to look at it at the side, it is a rectangle. So 5x by L, okay, and you have times 2, so you get 2 of them. So 10xL, okay. So in terms of x and L, the area of this shape is going to be 24x squared plus 10xL. Okay, now remember, we know that L is 9375 over x squared. So 24x squared plus 10x times 9375 over x squared. Okay, the x will cancel with the squared. And then I've got 10 times 9,375. Okay, which is what we were asked for. Okay, centimeters squared. Okay. In this video, I'm going to skip through the coordinate geometry and I'm going to put all of that together in a separate video. So I'm going to skip down to the next bit of geometry / area and volume, okay, which is down here. All right, we now have a triangular shape. Okay, the lengths of the sides of the triangle ABC are 9 units and 12 units and 18 units as shown in the diagram. Each side is divided into 3 segments of equal length. Okay. You've got 4, 4 and 4, 3, 3 and 3, 6, 6 and 6. Okay, so we've got triangle 4 and 3, 3 and 6, 6 and 4. The missing sides on all of them, 3, 6 and 4. They're all congruent triangles. Okay, and you don't need to prove congruency there in that case. So to find the perimeter, nice and easy, we're simply adding up all the sides. 6 plus 3 plus 4 plus 6 plus 3 plus 4. Okay, and shin 8, and that will get me 26 units. Okay, very harsh here, but without the word units, you actually lost 1 mark. Okay, so when you're not given units at all, okay, you still actually, you're given the word unit in the question, so you have to use the word unit in your answer. Okay, the area of the triangle ABC is 48 square units. Find the area of the shaded region. So again, I'm looking for this region in here, which isn't a regular shape. So I'm not going to solve that using the actual shape. I'm going to look at the triangles around it, which are regular shapes, and I do know how to solve. Okay, they are similar because all of the sides have the same proportion. So for example, 4 divided by 12 here. Okay, so for side A, 4 to 12 is in the ratio 1:3. 6 to 18 is in the ratio 1:3, and 3 to 9 is in the ratio 1:3. So their sides are all in the same proportions. All right. And they're all in the proportion. It doesn't matter which one you use. So I'm going to use 4 to 12. Okay. Similarly, you can use 3 to 9, or you can use 6 to 18. Regardless, they will all be in the ratio 1:3. Okay. Now that is for length. Okay, and we should know that area, okay, is squared. Okay, so if I'm looking at the side ratios for area, I also have to square that. So 1 squared to 3 squared. Okay, so the area scale is 1:9. Okay, and basically what this means is the scale is the small triangle is 1/9 of the larger. Okay, so therefore it is 1/9 of 48. Okay, if it's 1/9 of 48, we get a fraction for that. We get 16/3. Okay, so if the original shape was 48 square units, I'm going to subtract 3 of the triangles, each 16/3. Okay, which leaves me with 32 units squared. And again, if you didn't put in units squared there, you were actually penalized for marks. Okay. Okay, the next one I have already done out for you. Prove that they are similar. You cannot use ASA, SSS, or SAS, or HS. You have to prove that all of the angles are equal. Okay, you know that the lines are parallel. You're told that in the question. Okay, therefore this is alternate to this. This one here is alternate to this one here. And these two are vertically opposite. Okay, so all of the angles are equal. It then asks you to find AD. So AD should to be relatively easy to find. So I'm going to use this right angle triangle here. Okay. And I've got side lengths of 12 and 9. Okay, so it should have been relatively easy to find that AD, in this case, is equal to 15. Okay. It then obviously wants you to use that 15 to find OD. So if I go back up to my diagram, and I'm actually just going to rub out some stuff here. Okay, so, okay, in this case, I know that A to D is 15. Okay, if I know that A to D is 15, okay, let's call this bit here X. Let's just make that 15 a little bit clearer. So it's 15 from there to there. Okay, so if it's X from there to there, well then from there to there will have to be 15 minus X. Okay, and that's, you can call AOX if you want. Okay, now I know that the triangles ABO and CDO are similar, which means their sides are in proportion. Now remember, this angle corresponds to this angle. So the side BO, okay, so you got to be careful here with what sides correspond to what sides. So that angle corresponds to that angle. So, and let's say this angle X and X. So the dot and the X, the dot and the X. So the line between them, they correspond. Okay, so if I make a fraction of X over 15 minus X, okay, so those sides are in proportion. Now using the same triangle on top every time, so sticking with COD on top and AOB on the bottom of the fraction, I have X over 15 minus X, because these sides correspond to each other, and 9 over 11, because 9, the side length 9 and 11 correspond to each other. Okay. Now we should be able to do this algebra. Okay, some rearranging there gives you 11x is equal to 9 times 15 minus x. Okay, and in simplifying this, okay, you will be able to get, or you should be able to get, that x is equal to 6.75, and again we need that word units. You should always be following your answer for area, volume, and geometry with some form of a unit. Okay, right, the next one, some of you said that we haven't done trigonometry yet. True, but you have done trigonometry for your junior cert. Okay, we know that this is H, that's O because it's opposite the angle, and that's A. So I've nothing about H, I'm using O and A, so I've got tan of 30 is equal to R over 15. So 15 tan 30 is equal to R, and that can simply go in your calculator. You will get that 5 root 3 is equal to R. Okay, and again, yes, we haven't done that, but that shouldn't be of any difficulty to you. Finding the volume was very simple here. It was simply just putting into the volume formula a third pi R squared H. You know what R is. You were given 15, yep, in the diagram, so that should have been relatively easy there. Okay, the next one. A buoy at sea consists of a cone mounted on a heavy cylindrical base which floats with the cone uppermost. The buoy has an overall height of 6 meters, and the cone and the cylinder have equal volumes. Cone and the cylinder have equal volumes and equal radii. Find the vertical height of the cone. Okay, so first of all, we've got 6 meters. I'm looking for the height of the cone. Okay, so I've called it H. If the whole height is 6, well then this one has to be 6 minus H. Now remember, their volumes are equal. So you've got the cone, which is a third pi R squared H, has to be equal to pi R squared H for the cylinder. So the cone is equal to the cylinder. Okay. So I've got a third pi r squared, so I don't know what the radius is, by h for the cone. And then I've got pi r squared by 6 minus h for this one here. Okay. I can actually cancel out the pi's and cancel out the r squareds because I know they've got the same radius. I don't know they're the same height, so I can't do that for height. So I've got h over 3 is equal to 6 minus h. A number of different ways that you can solve this here. I'd probably multiply by 3. You'll have h is equal to 6 times 3 is 18 minus 3h. Okay, you'll have 4h is equal to 18. H is equal to 18 over 4, or 4.5 meters. And again, don't forget your units. Okay. The diameter of the cone and cylinder, so be careful here, some of you fell into the trap. The diameter is 2.5, which means the radius is 1.5. Okay, find the total volume of the buoy. You can find the cone and the cylinder separately, or you can just find one and double it, given that their volumes are the same regardless. You should have got 75 over 16 pi, or if you change it into a decimal, 4.6875 pi. Okay, again, that one should have been relatively okay. Okay, this last question here, my apologies, I didn't read it properly when I put it into your work. We have not done radians, okay, and pi in this case was expressed in radians. Okay, so in that case it means the pi is equal to 180. Okay, so you're literally subbing in 180 for pi there as well. Okay, but not to worry about that one too much.